In this video, I'll be talking about why benzene is aromatic, and I will give you a very useful table which you can apply this table to all of the organic compounds and identify which compound is aromatic and which is anti-aromatic, and how to apply this concept which I have already told you in my previous parts about aromaticity, where I mentioned about the 4 important rules which can be used to understand which compound is aromatic or not. So for example, if you are given this molecule which is benzene, the first question that you should be asking from yourself, is this compound cyclic? If the answer is yes, write yes, then move further. If it is not cyclic, that's the end. This cannot be aromatic. Do not go further into it. Okay, when you see a molecule, then ask yourself a second question, is this compound conjugated? If the answer is yes, then proceed to the next question about pi bonds. If it is not conjugated, that's it, don't go further. The next question is, ask yourself, is this compound have any pi bonds? If yes, then write down how many. So there are 3 pi bonds. And then ask yourself a next question, how many lone pair or pi electrons it does have? 0. There are no lone pairs in this compound in this case. Maybe later on we will see more examples where you can see the lone pair or pi electrons. But yeah, this is pi electrons inside the benzene, but we are talking about lone pairs. Hence, it does not contain any heteroatom, and carbon has fully saturated valency. That's why it does not have lone pairs. Okay, the next question is, count the number of pi electrons, total pi electrons. So if there are 3 pi bonds, so you multiply 3 with 2, because each pi bond contains 2 pi electrons. So 3 times 2 is equals to 6. Now the next and most important part is this compound obeys Haeckel's rule, which is 4n plus 2. And what is n? N is any number. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100 or up to 1000. So if you make a table using this n is equal to 0, then 4 times 0 is 0 plus 2, that will be 2. If you put 1 instead of n, then you times 4 times 1 is equals to 4, and then 8 plus 2, that is equals to 6. So if you see this molecule, this contains 6 pi electrons, and this says it should have 6. So it obeys Haeckel's rule. Now if you have proceeded all the way through a systematic way, then the answer should be yes. Is this compound aromatic? Yes, that's aromatic. This is how we can explain why benzene is aromatic based on all of these rules using this table. I hope you like this video. Please subscribe it if you haven't, and also please share it with your friends. Thank you. Bye.